Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good day everyone. So today we are going to learn about the chapter 2 part 1, which is the Fourier series and the application. So as you can see in my screen, okay, there are several course learning outcomes that we have to achieve throughout this semester. But for this chapter 2, okay, we will focus more on the CLO number 2, which is use the Fourier series to analyze and describe the signal linear time invariant continuous time in time domain. So for here, it is very important for you to learn and to understand to how to apply the Fourier series in order to describe the signal linear time variant and also continuous time system in the time domain. Alright, so when we talk about the type of the signal, there are several type of the signal that we are going to learn. Okay, the first one is we have to know the signal expression. So how we are going to express the signal. And then as you can see, okay, we are going to learn about the time domain signal. So what is actually the time domain signal? And then we are also going to learn about the frequency domain spectrum, in which you have to you need to able to draw and sketch the spectrum, the spectrum of the frequency, okay, and also how we can draw the spectrum. Okay, there are two spectrum. Okay, in this chapter, okay, you need to know about the phase spectrum and also the amplitude spectrum. Okay, later on we are going to learn about that. Okay, and then by using and then from the frequency domain spectrum, okay, you can draw the single-sided spectrum. And then how from the single-sided spectrum we can also draw the double-sided spectrum. Okay, and then to get the expression, okay, to get the signal to draw the double-sided expression, you have to get the complex expression, because when you have the signal, you have to convert in terms of the complex exponential so that you can draw the double-sided expression, double-sided spectrum. Okay, so now in this chapter 2, okay, we are going to learn about the sinusoidal of the signal, how to represent the signal, and then we are also going to learn about the Fourier series and effect of the Fourier series characteristic. But for this particular part, we only will learn how to express, how to represent the signal first, and then for the part 2 we are going to learn about the Fourier series and effect of the Fourier series characteristic, and then this is part 1. Okay, and then this one gonna be part 2, and then this one gonna be part 3. Okay, so it is very important in the Fourier series, it is very important for you to refer to the appendices that I asked you to print it out. Okay, so it is very important. But for the first part, okay, you have to do some revision on the electrical circuit analysis, because in your electrical circuit analysis, I believe you have learned about the sinusoidal representation. Alright, okay, so let's take a look. Okay, when we want to learn about the sinusoidal signal, okay, you have to know the signal expression. Okay, you have to know the time domain graph. You have to know the frequency domain spectrum. Okay, you have to know how to convert the signal in terms of the phasor representation. Okay, you have to know how to represent the signal in terms of the complex exponential, and then we are going to learn some revision on the periodic signal, because in your chapter 1, okay, we have learned that the periodic signal is repeated by the period, okay, by the period of t. Okay, so you know that the t is equal to 1 over f. Alright, okay, so now let's learn about the signal expression. Okay, for the signal expression, okay, sinusoidal is a common type of the signal that is used in the the various system. Okay, so this is the common time varying voltage signal, in which you have the you have the amplitude. This one is the amplitude. Okay, and then you have the angular frequency, and you have the phase. All right, you have the phase. This one you have learned in your electrical circuit analysis. All right, so commonly we are going to express our signal in the cosine, but we also can represent our signal in the sine, but preferable we need to express in this signal line system. You have to express the signal in terms of cosine. Okay, so after this we will do some revision on the electrical circuit analysis, how to convert the sine signal into the cosine in terms of the phase and so on lah. Okay, so alright, it also can be written as a sine omega t plus theta, but with difference of the pi over 2. Okay, sinusoid can be presented in the time domain and the frequency domain. Alright, so now, okay, this is the revision for the electrical circuit analysis, how to convert the how to convert the sine signal to the cosine in terms of the phasor. Alright, so this is the notes. Okay, later on you can refer. Alright, okay, so phasor, what is actually the phasor? This is the revision, the revision for the electrical circuit analysis. The phasor is the complex that represent the amplitude and the phase of the sinusoid function. It can be represented in one of the following three forms. The first one is the rectangular. Okay, the rectangular, you may refer to this graph, okay, to this sketch. Okay, rectangular, meaning that the z is equal to x plus jy. What is the j? J is the imaginary value. Alright, from here, okay, we can represent our signal into the polar form, okay, z is equal to r phase theta, and then we also can represent our signal in terms of the exponential. So I hope that you can do your revision because this one is already learned in the electrical circuit analysis. Alright, so this is the review, how to do the addition and the subtraction, also several operation of the complex, and also the mathematical expression, and also the phasor form. Alright, okay, so for the phasor, a full cycle of the sinusoid can be represented by the rotation of the phasor through 360 degree. Okay, so from here you need to remember that for this particular angle, it is measured by using positively counterclockwise. Okay, positively counterclockwise, meaning that counterclockwise lah. Okay, anti-clockwise. Okay, so now this is the tips that I applied to my student previously. Okay, so for example, in order for you to remember, sometimes it's quite difficult. Okay, sometimes it's quite difficult for us to remember the formula. So that is why, okay, the tip is that if you want to remember, okay, the conversion, okay, just remember how to learn this sketch. Okay, first of all, what you need to do is you sketch the x-axis and the y-axis. Okay, the x-axis will be your cos omega t. Okay, the other way around is negative cos omega t, and then for the y-axis is the negative sine omega t, and below one is the positive sine omega t. Okay, so now remember, whatever the signal is, okay, we need to represent our signal in terms of cos omega t. Okay, that is the common one, that is the basic one, that is the general one that you need to represent your signal. So what will happen is that, let's say, okay, remember the angle are measured positively anti-clockwise, meaning that, for example, from here, okay, to here, okay, this is a positive. For example, this one to this one is, okay, 0, okay, 90 degree, okay, 180 degree, 360 degree, like that. Okay, so now how can we remember this sketch? Okay, let's say this is your main, okay, this is your main signal representation. Now, given to you, for example, the sine omega t. Alright, you need to convert to the cos omega t. So how? Okay, so from the sine omega t, okay, to the cos omega t. Okay, so what is the formula? In order to get the sine omega t, the cos omega t minus with 90 degree. Minus with 90 degree because of what? Because from the cos omega t you want from the sine omega t you want to get the cos omega t. Okay, so that is why, okay, from the sine omega, okay, to get the sine omega t is cos omega t minus 90 degree. Okay, meaning that cos omega t minus pi over 2. Okay, alright, so let's say I give you some example. Okay, I give you some example. Okay, let's say given to you, and it's very important for you to have the positive cos omega t. Positive cos omega t. So, okay, to do this, okay, let's say given to you the negative cos omega t. Okay, how to convert to positive cos omega t? Okay, negative cos omega t is equal to, okay, so this one is equal to, okay, if we go here, okay, we can get cos omega t plus 180 degree, or we can write cos omega t plus pi. Right? Okay, because of the 180. Because remember, this is also the positively counterclockwise. Okay, positively counterclockwise. Okay, so I hope you do understand how to convert to the signal. Okay, the common one. But at the same time, you also can write cos omega t minus pi. Because of what? Because the cos omega t is leading the negative cos omega t. Okay, in other way around you can choose either one. Alright. Okay, so next. Okay, so the phasor, it is transform a sinusoid to and from time domain to the phasor domain. Okay, so this is the formula. Okay, this is the time domain common representation. Okay, we use the cos, and then from here we can convert to the phasor domain. Phasor domain, this is your amplitude and this is your phasor. Okay, the amplitude and phasor are two principal concerns in study of voltage and current sinusoid. Okay, phasor will be defined as a cosine or sine function in our all preceding study. If a voltage or current expression is in the form of sine, it will be changed to cosine by substituting the phase. Okay, so meaning that, what does it mean? Okay, so remember, whatever it is, the common formula, the common general equation is the cos. Okay, from the cos you can get the phasor diagram. You can convert the phasor, the time domain to the phasor domain automatically by copying the angle. Okay, but if you want to convert the sine of the time domain to the phasor domain, okay, it will be negative 90 minus 90 degree. Okay, so from here, if the current, you can see that you can automatically copy the phase, the theta. Okay, and then if you have the sine, you have to minus with the 90 degree. Okay, why you have to minus with the 90 degree? Because our common formula is theta, cos theta. Okay, alright, this one also you have learned about the leading and the lagging direction. So I believe that, okay, you know that. Okay, again, the phasor, the angle is measured positively counterclockwise. Okay, so meaning that from here we can say that the V is leading the I. Okay, V leading, okay, or I lagging the V by several angle. Okay, so for the time domain, okay, the sinusoid can be sketched in the time domain graph. Okay, so the time domain graph, okay, consider this is the time varying voltage signal. So you know that this is the angle, this is the amplitude, okay, and then this is the frequency, all right, the angular frequency omega, and then the phase shift, the angle. Okay, so now just now I mentioned that from the frequency domain you can sketch the single-sided. This one is very important in our circuit and signal. Okay, all right, single-sided spectrum. Okay, what does it mean with the single-sided spectrum? Okay, each sinusoid signal has frequency. All right, we know that in our signal we have the frequency, we also have the amplitude, and we also have the phase. That is the common one. Okay, and then the amplitude and the phase can be plotted with the frequency to produce spectrum signal, meaning that for the x-axis it would be your angular frequency. All right, and then for the y-axis it depends. If it is the amplitude spectrum, so meaning that your amplitude, your y-axis is your amplitude. Okay, meanwhile if you are sketching the phase spectrum, meaning that your amplitude would be the phasor. Okay, for example, okay, I give you your example. Okay, so now again remember your x-axis is your frequency, because now we want to sketch the frequency domain signal. All right, so this one is the frequency, this one is frequency. All right, let's say if you can see here, this is the given to you the signal. Okay, so this one, you know that this one and this one is your omega 1. Okay, this one 2 pi f is omega 2, because omega is equal to 2 pi f. Alright, so we can directly sketch the label. Okay, omega 1, omega 2, omega 1 and omega 2. For both amplitude spectrum and also the phase spectrum, the x-axis will be the same, which is your angular frequency. That is why we are referring to the frequency spectrum. Okay, the frequency domain signal or the spectrum, single-sided. Okay, but whenever you want to draw this one, okay, you have to make sure that you represent your signal in terms of cosine. Okay, in terms of cosine. All right, again I repeat, you need to represent your signal in terms of cosine. Okay, so remember, since we have the amplitude spectrum, okay, amplitude spectrum, so meaning that you have to focus more on the amplitude and also the frequency. Okay, so the frequency you can get from the signal given. Okay, so 2 pi f1, so meaning that omega 1, 2 pi f2, meaning that omega 2. Alright, so since it is amplitude spectrum, so take a look the first component. For the first component, your amplitude is A1, so that is why here is the A1. Okay, so for your second component of the signal, okay, your amplitude is A2, for given to you the omega 2. Okay, that is how to draw the amplitude spectrum. What about the phase spectrum? Alright, if you have the phase spectrum, okay, given to you now, okay, the theta 1 is belong to omega 1, right? So again, your x-axis is omega 1, okay, your this one omega 2, for the second component omega 2, the first component is omega 1. Alright, so let's say given to you, if you can see here, your phasor 1, your theta 1 is belong to omega 1, so you can just draw the omega 1. The theta 1. Okay, same goes to the theta 2. Okay, since this one is negative, so you have to draw the downside. Okay, negative theta 2. Okay, that is how to draw and to sketch the single-sided spectrum. Okay, so remember, whenever you are asking to sketch the single-sided signal, okay, it is very important for you to have two types, which are the amplitude spectrum and also the phase spectrum. Okay, it is very important. Okay, so now let's continue. Okay, let's do this example. Okay, for example, okay, given to you the signal below. Okay, so you have the A cos omega t minus B cos 2 omega t plus C sin 3 omega t. Okay, so remember, whenever you want to represent your signal in terms of frequency domain spectrum, okay, it is very important to convert in terms of cosine, positive cosine. Okay, so when you write the positive cosine, okay, you know that the first component is A cos omega t naught. It is okay. Alright, what about the B? Negative B, okay, cos, okay, 2 omega naught t. Alright, so remember how to convert the negative cos omega t. Okay, so just draw. This one is cos, this one is sine, this one negative sine, positive sine, negative sine, no, positive sine, this one is negative sine, okay, this one is cos sine. Okay, so now you have the negative cos. Okay, negative cos. Okay, so from here, you want to get the negative cos. So, plus pi. Right? Plus pi. Because it is measured positively counterclockwise. Okay, so therefore, it will become B cos 2 omega naught t plus pi. Okay, alright. Okay, so now what about the sine 3 omega t? Okay, C sine 3 omega naught t. Alright, so from cos, how to get the sine omega t? Because now you want to represent your signal in terms of cosine, right? Okay, so this one is minus because this one is positive counterclockwise. Okay, positive counterclockwise. So, but it is lag. The sine is lagging the cos. Alright, the sine is lagging the cos. So, it is minus pi over 2 because 90 degree, right? Okay, so we can get C cos 3 omega naught t, alright, minus pi over 2. Okay, it doesn't matter whether it is positive or negative. Okay, the rules is that you need to convert the cos. Okay, as long as you remember how to convert the negative sign, any sign, okay, cosine or sine to the positive sign, positive cosine. All right. Okay, that is why, okay, you get this one. Okay, A cos omega naught t plus B cos 2 omega naught t plus pi. Okay, and C cos 3 omega naught t minus pi over 2. Alright. Okay, so you can have any formula lah to remember, but I think sketching is one of the tips ataupun the tips lah. It might be helpful for you to remember the conversion. Okay, because the conversion is not given at all. Okay, you have to remember by yourself. Okay, so now how to sketch? Okay, how to sketch by represent the signal into cosine. How to sketch in the frequency domain? Okay, frequency domain, which is when we talk about the frequency domain, you need to plot the amplitude spectrum and also the phase spectrum. Okay, it's quite easy because already given to you the amplitude and also the phase spectrum. It's just that you need to remember the x-axis would be your angular frequency, your frequency. Okay, so now from here, okay, let's take a look each component. Okay, for the each component, okay, you have this one is your omega naught. Okay, this one you have 2 omega naught, and this one you have 3 omega naught would be your frequency, angular frequency. So for both spectrums, okay, amplitude and also the phase spectrum, you just follow the plot you just need to put the x-axis. Okay, omega naught, 2 omega naught, and 3 omega naught. Okay, so now what about the amplitude spectrum? Okay, since it is the amplitude, what you have to do is, okay, you just need to take a look the amplitude. Okay, and then for the amplitude spectrum, the first component, the amplitude is A. That is why A. Alright, for the second component, okay, the amplitude is B. So B. And then for the third component, okay, since we don't even know the magnitude of the A, B, and C, so we just can draw the signal lah. Okay, the signal. Okay, alright. So C, this is the amplitude spectrum. Alright. So what about the phase spectrum? Phase spectrum meaning that the amplitude is the phasor. Okay, and then you need to take a look the first component, the second component of your angular frequency, and the third phase of your angular frequency. So now let's take a look the first component. Okay, so first component, since we don't have any phase angle, all right, so you just can ignore, because not ignore meaning that let it be. Okay, all right. Okay, so for the second component, okay, your phase, your theta is belong to your second component, right? Second angular frequency. So therefore, you can draw pi. Alright. And then what about the third component? The third component, okay, belong to 3 omega naught, but you have to be very careful. Okay, take a look the sign, whether it is negative theta over 2 or positive. If it is negative, so downwards. Okay, or if it is positive pi over 2, it is upwards. Okay, it's quite easy. Alright, next. Okay, sometimes, okay, given to you the signal that can be combined together. Okay, for example, given to you the an cos omega nt plus bn sin omega nt. Okay, with that being said, we can refer that, okay, the cos and the sine share similar frequency, share similar angular frequency, okay, in which we have the omega n, okay, for both sine and cosine. For this particular situation, what you can do is that you can combine the signal become an cos omega nt plus theta n. Okay, and then what is the formula? It is not given to you, you have to remember by yourself. Okay, if the cos and the sine share similar angular frequency, so you can convert to the an cos omega nt, okay, plus with the phase ataupun theta n. Okay, so how to calculate the an? Okay, so you need to make sure that your an must belong to the cos, alright, and your bn is belong to the sine. Okay, don't get confused. Okay, you cannot put the sine is an, you cannot put the bn for the cosine, you cannot, it is wrong. You need to follow this formula. An is belong to the cos and bn is belong to the sine. Okay, therefore, how to calculate the an? An is this one, an belong to the cos, bn belong to the sine. Okay, so theta n is tangent, reverse tangent, negative bn over an. Alright, so this is how, and then finally from this one we can convert. You can convert. Okay, the sharing frequency, angular frequency of the cos and the sine become cos lah. Okay, so this is the formula. So from this signal, trigo signal, so you can convert into the phase shift and also phase shift. You can convert into the amplitude spectrum and also the single sided of the amplitude spectrum and the single sided of the phase spectrum. Okay, so let's take a look at the example. Okay, sketch the magnitude and the phase spectrum of a signal which is given in the form of trigonometric Fourier series below. Okay, so here you have, alright, you have the okay, you have the Vt 1 plus sine omega t naught omega naught t 2 cos omega naught t minus 2 cos 2 omega naught t plus 1 over 4. Okay, remember, first of all, we need to convert all in terms of cosine. Okay, but at the same time, you have to take a look, is there any frequency sharing? Okay, is there any frequency sharing? The second one is convert to the cos. Okay, so now from given signal, okay, from given trigonometry signal, okay, we can see that your sine omega naught t share okay, similar angular frequency with the 2 cos omega naught t. Okay, therefore okay, what you have to do is you have to convert in terms, okay, whenever you want to convert in terms the cos, right, it is very important to represent our signal, our trigonometric signal in terms of the cos, because it is the common signal. Okay, so to convert this one, okay, remember the an belongs to the cosine, whereby the bn is belong to the sine omega t. So now you can rearrange from sine omega naught t plus 2 cos omega naught t become 2 cos omega naught t plus 1 sine omega naught t, because you have to make sure the an belong to the cos, okay, bn is belong to the sine. Okay, so from this formula, okay, you can just calculate, right? You just can calculate, okay, an squared plus bn squared. Okay, the problem is that when you mismatch the an and also the bn, your phasor, okay, your angle will be wrong, akan salah. Okay, that is why very important for you to indicate the an belong to the cosine, the bn is belong to the sine angle. Okay, sine angular frequency. Okay, so now you can calculate by using this formula. Okay, so from here, okay, you can get the sec 5 cos omega naught t minus 2556 angle, okay, degree. Okay, so you just can use the formula directly. Okay, so now from here, okay, you just can convert this one, right? This one is okay. Alright, now it's okay. This one no problem at all. Okay, what about this one? Okay, we don't want the negative cos, we want the positive cos. Okay, so remember from the negative cos, okay, to get the from the cos to get the negative cos, so you can have negative cos equal to cos plus pi over pi lah, okay, 180. Okay, that is why here pi over 4 your phasor plus with the pi 180 degree. Alright, so now when you solve, you can get Vt1 equal to 1 plus sec 5 cos omega naught t minus 26.56 plus 2 cos 2 omega t plus 5 pi over 4. Okay, so quite easy and straightforward. Okay, so now how to draw the amplitude spectrum? How to draw the amplitude spectrum? Let's take a look one by one. The signal, the converted signal just now. Okay, so now you have converted the signal here. Okay, this is your trigo signal. Okay, this is your first component. This is your second component, second angular frequency, and this is your third angular frequency. Now, whenever we want to draw the amplitude spectrum, of course, we have to identify the omega. Alright, the omega. Okay, since this omega is equal to 0, so you can directly to draw this one becomes 0, this 0. Okay, the omega here is 0. Okay, so 0. Okay, what about the amplitude? The amplitude is 1, so that is why become 1. Okay, for the second component, okay, your angular frequency is omega naught. That is why for the amplitude spectrum, it become omega naught. Okay, and then for the third component, become 2 omega naught. Okay, that is the third component. Alright, the third angular frequency. So let's take a look. The amplitude belong to the omega naught. Okay, the amplitude belong to the omega naught is equal to sec 5. So you can draw sec 5 here. What about the third component? The amplitude belongs to 2 omega naught is 2. So that is why 2. Okay, so now how to draw the phase spectrum? Okay, of course this one is the omega, this one is your phasor. Okay, so for the first, just follow the angular frequency. This one is 0, this one is omega naught, this one 2 omega naught. Okay, this one you need to label based on the given spectrum, given signal. Okay, 0, omega naught, 2 omega naught. Okay, so now let's take a look the phasor. for the omega naught is equal to 0, okay, your phasor is 0. So you don't have to draw anything. Okay, you don't have. Let it be. Alright, for the second component, alright, the negative 26.56. Okay, negative. So negative. So up downwards. Negative 26.56 angle. Okay, you have to put the label. Alright, so what about the third component, the third angular frequency of 2 omega naught? Okay, the 2 omega naught is 5 pi over 4. Okay, so 5 pi over 4 is equal to 5 angle. So positive, since it is positive, so upwards to 5 degree. Okay, so this is how to draw the magnitude and phase spectrum. Magnitude, or sometimes it is mentioned about the amplitude spectrum. Okay, so first of all, it is very important for you to convert the signal, to represent the signal in terms of cos. Okay, if it is not, but you have to analyze in the given signal whether is there any frequency sharing or not. Okay, alright. So this one is the phasor representation. I believe you have learned. Okay, because since the signal is measured positively anti-clockwise, so that is why it is positive. Okay, okay. So the complex exponential representation. Okay, so remember the signal can be represented into 3 types, right? The first one trigo, the second one is the phasor, and then the third one is the polar. Okay, so in terms of the polar, alright, in terms of the polar just now, okay, let's take a look back. Okay, so you have the polar, okay, you have the you have the rectangular, and you have the exponential. Okay, so for the exponential, okay, you can convert the signal from trigo to the exponential. Okay, from trigo to the exponential. Alright, so in general, we know that this is your signal. Okay, the signal representation in the trigo. Okay, so based on the Euler, okay, we can convert your, for example, cos omega t. It can be cos omega t lah, kan? Cos omega t. Okay, you can convert to negative j omega t. Okay, plus exponent negative j omega t over 2. Okay, for the sine omega t, negative j omega t minus exponent negative j omega t divided by 2j. You have the j, the complex number, the complex value. Alright, so now from here, if you convert from the trigo to the apa namanya orang kata, to the Euler or complex exponential, okay, you can see here there is double-sided representation in which you have the positive j and you have the negative j. Alright, so from here we can say that from the exponential, complex exponential representation, you can draw double-sided signal. Just now, okay, from the trigo, you only can draw the single-sided because you don't have any positive or negative. Alright, but if you are being asking to convert in terms of the complex exponential representation, meaning that you can draw, you can represent, you can plot the signal in terms of the double-sided signal. Okay, so as you can see here, okay, the formula, okay, a cos omega t plus theta. Okay, so this is the formula a, because technically this one is belong to here, alright, over 2. Okay, that is why. So but since this is the whole number, you can just put here. Okay, so this is the difference between the time domain or polar representation and the exponential representation. Okay, you have the imaginary, okay, in which, as you can see, okay, you have the positive j and negative j. Alright, so from here you only have one polarity. Okay, so From the exponential form, as I mentioned just now, you can represent the signal into the double-sided spectrum. Okay, so this one is belong to the positive side and this one is belong to negative side. Okay, negative side. Okay, this one is belong to positive side. For both, okay, you need to draw for both. Okay, the amplitude spectrum and also the frequency, the phase spectrum. Okay, again, the x-axis is similar. The x-axis is your angular frequency and the y-axis, it depends if it is the amplitude spectrum. So it is the amplitude. And if it's the phasor spectrum, so it is the phasor, the amplitude is the phasor. Okay, so now let's take a look how actually to draw this one. Okay, alright, for the amplitude, okay, so we know that at the positive side, because you can expand this one, right? Okay, so for the positive side, okay, you can see that your amplitude also V0 over 2. This is positive side. For the negative side, your amplitude is also V0 over 2. That is why, okay, for the both side, this is the positive side, okay, it is the V0 over 2. But same goes to the negative side, okay, negative angular frequency. This one is negative, because when you multiply, you become negative omega t. So that is why for the negative side of your angular frequency, the amplitude is also the same, which is V0 over 2. Okay, so let's take a look the phase spectrum. Okay, the phase spectrum again is very important for you to expand because sometimes when you didn't expand, it is quite tricky for you. All right, because the phase is after the angular frequency. All right. Okay, so now this one is the positive side, right? Okay, belong to omega t. This one omega. Okay. And then the negative side, when you expand, it becomes negative j omega t minus theta. Alright. So for the negative side, for the left side is the negative omega. Negative omega. So for the negative omega, when you expand negative, okay, negative and positive multiply, you will get negative theta. That is why when you want to draw the phase spectrum for the double-sided, it is become negative theta. Okay, but for the positive side, positive or right side, okay, positive phasor, when you expand, okay, the positive j, okay, multiply, dia akan jadi j theta, right? J theta. So the theta is positive. So that is why for the positive side, the theta is this one. Okay, what happened if the exponent, okay, negative j omega t, alright, become negative theta, given the example from the question. So what will happen? Okay, the negative you have to expand, so meaning that from here you can say that your angle is theta, positive theta. Alright, so it depends. Okay, later on we will take a look at the example so that you can be more understand lah. It can be more understandable. Okay, so from here, the F domain signal versus the exponential. Okay, so you can see this is the comparison between the frequency domain and also the exponential form. Okay, so from the F domain, the frequency domain, you can get the single-sided because you don't have any positive or negative. But for the exponential, okay, you have the positive and negative of the angular frequency since you have the negative j and also the positive j. Okay, so need to be very careful, okay, while sketching the amplitude spectrum and also the phase spectrum, especially for the double-sided. Okay, so now let's take a look at the example. Okay, the example for the continuous periodic signal, xt is equal to 2 plus cos 2 pi over 3, okay, plus 4 sin 5 pi over 3. Represent the xt in the form of complex exponential Fourier series, and then we know that from the complex we can plot the double-sided frequency spectrum, which is in terms of magnitude and also the phase. Alright, first of all, you have to analyze the signal given, whether is there any sharing of the angular frequency. So you can see that there is no sharing for the angular frequency. Okay, so for this one, your angular frequency is 0. So this one, your angular frequency is 2 pi over 3. And for the third angular frequency, this one is 5 pi over 3. 5 pi over 3. But remember, again, you need to back to the basic where you need to convert, you need to represent your signal in terms of the cos. So 4 sine 5 pi over 3t. Okay, so you need to convert to the cos. 4 cos 5 pi over 3t. Okay, so how to convert? Okay, how to get from cos to sine? Okay, negative pi over 2. Okay, so you have cos, you have sine. Given to you the sine, so we need to represent the cos. So for cos, okay, this one, if this one is the positive, okay, but from the cos to get the sine, okay, it is negative pi over 2. Okay, that is why negative pi over 2. Okay, so this is the, okay, so this is the signal 2 cos, okay, 2 plus cos 2 pi over 3t, okay, plus 4 cos 5 pi over 3t minus pi over 2. Okay, so it doesn't matter, okay, it doesn't matter. Okay, so now how to write the complex? Okay, so remember the basic formula. Okay, for the cos, what is the basic formula? Okay, for the cos, let's say omega t, you can write, okay, a, okay, and then exponent j omega t plus exponent negative j omega t over 2. Alright, okay, so now 2 plus cos is become what? Become exponent j 2 pi over 3t, okay, plus exponent negative j 2 pi over 3t, right? Negative, okay, over 2, okay, and then plus with the 4, okay, and we need to convert 4 cos 5 pi over 3t minus pi over 2, right? This one, okay, so it become exponent j 5 pi over 3t minus pi over 2, okay, plus exponent negative j 5 pi over 3t minus pi over 2, okay, divided by 2. Alright, okay, so you need to, okay, inside the bracket you need to just follow whatever inside the bracket. Okay, whatever inside the bracket is, the difference is for the negative or positive here. Okay, so now, okay, you can draw, you can simplify, become 2 plus 1 over 2 exponent j, this one, right, 2 pi over 3t, okay, plus exponent negative j 2 pi over 3t, okay, plus 4 over 2, 2 exponent j, sorry, okay, exponent j 5 pi over 3t minus pi over 2 minus plus, right, because of the cos, okay, plus exponent j 5 pi over 3t minus, this one minus, just follow, okay, over 2. Okay, so from here, okay, you already get the first question, represent the signal xt in the form of complex. This one is in terms of complex. So now for the question number 2, sketch the double-sided. Okay, for the double-sided, it is very important for you to analyze each component. This one is omega equal to 0. Okay, this one omega become 2 pi over 3. Okay, for this the third component, your omega become 5 pi over 3. Okay, let's say we want to draw the amplitude spectrum. Amplitude spectrum. This one is omega, this one is your amplitude, right? Okay, so your x. Okay, so your amplitude is omega, it becomes 0. This one is omega 2 over 3, and this one 5 pi over 3. Okay, alright. So remember, since you represent in terms of exponential, you need to have double-sided 2 pi over 3, and another one is 5 pi over 3. Okay, alright, this one is negative. Alright, so let's take a look one by one. For this particular one, okay, your amplitude is 2. So become 2. Okay, alright, so positive side of 2 pi over 3. Okay, your amplitude is 1 over 2. 1 over 2. Okay, what about the negative one? Because you expand also, you will get, because of the amplitude is maintained. 1 over 2. Let's take a look at the third component. For the third component, the omega is 5 pi over 3. Okay, the amplitude belongs to the omega 5 pi over 3 is also the 2. For the negative side, also 2. So 2 become 2. Okay, so now what about the phasor? Phasor is quite tricky. 2 pi over 3, 5 pi over 3 angular frequency, negative 2 pi over 3, negative 5 pi over 3. Okay, so we know that for the first component, the angular frequency is 0. The phasor is 0. No, the angle is 0. No angle at all. Okay, tak ada angle. No angle. Angle is 0. What about the angular frequency of 2 pi over 3, the phasor? Phasor also 0. You don't have any angle for the both side of the 2 pi over 3, right? So let it be. Okay, so now let's take a look the phase for the 5 pi over 3 of omega. Okay, so for the positive side, since it is negative pi over 2, okay, technically you can draw this way, negative pi over 2. Okay, what about the negative side? Negative side is negative j, right? So for the negative side, if you expand, you will get positive pi over 2. That is why positive pi over 2. Alright, so this is how you plot the phase spectrum of the double-sided and also the amplitude spectrum for the double-sided. It is very tricky for you to draw the phase spectrum, especially for the double-sided. You need to be very careful. Okay, so at the end, okay, I hope you can do this one. Okay, what about this? Given to you the GT 4 plus 3 of 3.4 cos 10t. Okay, 1 over 2 cos 10t. Okay, so here share the same. So technically when you share the same, you can have 3.4 plus 1.2, you will get 4.6, right? Cos 10t. Okay, this one direct. Okay, sin 20t plus 40 degree and 5 cos 20t 40 degree. Okay, so this one. Okay, so technically if you can see here, your angular, you share same angular. Okay, and also the degree. Okay, so I hope you can solve this one lah. Okay, okay, so after this I will continue for the chapter 2 part 2 on the next video. Thank you.